Okay, so our parent function for a square root is y equals the square root of x. So I don't really have a vertex, I just have a starting point, but the starting point is going to be my hk value. So if I'm asking you for the starting point of a square root, I'm asking you for the hk value. So if I look at the parent function, what's the hk value in the parent function? 0, 0. 0, 0. So I'm going to plot that point first. 0, 0. So then, is there a table here? Is there a table on your paper? No? Okay. So I'm going to go through, if I want to look at my foldable, or I can generate it. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So this will give me a few points that I can plot for my parent function. So over 1 up 1, over 4 up 2, over 9 up 3. And I have this kind of half of a sideways parabola. All right, so there is my parent function in the table form, my parent function as a graph. So now we can write down our domain, right? We can write down the domain. We can either look at the graph or we can look at our concept map. What's the smallest x value we see on this graph? 0. And 0 is included, and then we go to infinity. So in a quadratic, where did we see that with quadratic? How is that similar to a quadratic? Where do we see 0 to infinity? It's the range. So the domain of the square root is the range of the quadratic. Well, doesn't that mesh with what we said yesterday? The inverse is the domain and range switch. All right. Let's look at the range of this picture. Looking at my green graph here, what's the range? From 0 to infinity. If I think back to a quadratic, what's the domain of a quadratic? It's all real numbers. Well, how come this isn't all real numbers? It's only half. Well, hang on. Because really, if I had taken my quadratic and I reflected it across the y equals x axis, I would have this, right? Does this look more like a parabola on its side? So why do I not have that red part on my graph? Yes, ma'am. I can't take a square root of a negative number. But if I'm just talking about a reflection, why do you think why wouldn't I have that bottom part? What have we been studying all year? You're on the right track. What? We have been studying functions. Is this a function? No, it fails the vertical line test. So what we're doing is we're restricting our domain so that I can be studying a function. I want to study the square root function, not the square root relation. Okay? Because really, if I took my parabola and I reflected the whole thing, I would have a sideways parabola, which is not a function. So that's why I don't have all real numbers there as my range. The point pattern, if I think back to quadratic, for a minute, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. How is this similar to what we just wrote? It's the inverse. We flipped the x and y's, right? That's kind of what we've been studying. We're flipping the x and the y's. This is my square root of x. So the x and y's are flipped. All right. So part of what you're going to do on your homework tonight is we're going to go back to transformations. So the transformation form still involves the hk, which moves our parent function left and right. It has an a value, which stretches vertically, or if it's negative, it reflects vertically. We've not spent a whole lot of time on b. We didn't spend a lot of time on b because we couldn't see it. But now with the square root function, if I've got a square root function that looks like this, and I reflect it horizontally, you can see that change. So we're going to be looking at b in this unit. more than we've looked at previously. All right, so we want to graph the following square root functions. At the bottom of this, your paper, you've got a little bit of space. We're also going to describe the transformations because you have to do that on your homework tonight. So we want to find the starting point. We want to find our HK value. And then we're going to graph this. So number one, what is the HK? -2 and 0. Good, that's my starting point. -2 and 0. So how are we going to transform the parent function? What is the +2 tell me to do? Move my graph which direction? To the left 2. So down at the bottom of your paper, you've got a space. I want you to write left 2. All right, right below the graph, you've got space, right? Left 2. What else are we going to do? What does this -3 tell me to do to my graph? No, we're not compressing, we're stretching. The A is what you think it should be. It's the B value that's opposite. The A value, we're going to do a vertical stretch. That's the 3. And then what does the negative tell me to do? We're going to do a vertical reflection, which is a reflection across the x-axis. So these are the 3 things that we're doing to the parent function. All right, so let's do those things. So the first thing I'd like to do is I'd like to plot my starting point, my HK, my -2, 0. Here we go, there's -2, 0. All right, I'm going to use the idea of the counting scheme. So I've got a little table to fill in. I'm going to fill in my parent function. My parent function, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. And I'm going to multiply all of these y values by this -3. Okay, all of these y values times -3. All right, so this is still 0, this is -3, this is -6, this is -9. These are not points on the graph, this is my counting scheme. This is telling me from my starting point, I am going to go to the right 1 and down 3. So from my starting point to the right 1 and down 1, 2, 3. From my starting point, I'm going to go to the right 4 and down 6. So from the starting point, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. From my starting point, I'm going to go to the right 9 and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 6, 7, 8. And then I down here a little bit, down 9. Okay, so here's my graph. And now I can talk about the domain in the range. So what's the smallest x value on my graph? -2. And x goes to infinity. What's the smallest y value on my graph? -infinity. And it goes up to 0. So we're going to see the h value. Do you see the h value is -2? We're going to find that somewhere in my domain. And the y value 0, we'll see that somewhere in our range. Just depending on if the graph reflects or not, if it's in the first position or the second position. What do you guys think about that one? Not too bad? It should feel somewhat familiar, at least in terms of how we're stretching and moving around. All right, so let's look at our second example. Now, our second example has something in front of x. We have a b value. What you must do is factor the b value out. If I come back to the transformation form, do you see that I have the b value and then I have parentheses? That's because the b value has been factored out. So the very first thing that we need to do is rewrite this, factoring out a -1. So this would be -1 and x minus 5. inside the square root and then the plus 3 outside the square root. Now that looks just like the transformation form that we wrote at the top of our notes. Now you can identify HK. So looking inside the parentheses, what's the H value? 5. And then what's the K value? 3. So there's my starting point, right? That's my HK. So 5, 1, 2, 3, 4, 5, 1, 2, 3. All right. So I'm not going to have to stretch this graph vertically because there's no A value. I do have this negative as a B value. So what does that tell me to do? Right, it's a horizontal reflection. So instead of moving to the right and up, I'm going to move to the left and up. But I can use the counting scheme. So starting at my starting point, I'm going to go left 1 and up 1. I'm going to go left 1, 2, 3, 4, and up 2. I'm going to go left 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2, 3. All right, so there's my reflection horizontally. If you're unsure, we can use that table below. You don't have to use the table. If you want to use the table, you can use the table. So what the table would look like, here's my parent function. I multiply the y value, not the y values, the x values this time. I divide by -1. So basically this would be negative, negative, negative. So that tells you left 1, up 1, left 4, up 2, left 9, up 3. So that's what my table, how my table could be affected with the counting scheme, if that's helpful. If I described the transformation, what's the first thing that you would want to tell me about? The H value, which is right 5, right? So I'm going to say right 5. That's the first thing you would tell me. Right 5. What's the second thing you would describe? The B value. So what is the B value doing to my graph? Horizontal reflection, or reflecting horizontally, either way. Horizontal reflection. And then what's the last thing that I would describe? The K value. And what's the K value doing to my graph? Moving it up 3. Do you guys remember the order that you described the transformations? You do H first, and then you do the B, and then you do the A, and then you do the K. That's the order that you're going to describe those to me in, because you do have to do that on your homework. Last thing on this page is the domain and the range. So what is the smallest x value on my graph? -infinity. So I'm going from -infinity to 5. What's the smallest y value? 3. And I'm going to infinity. And again, notice that the h is going to be somewhere in the domain, and the k is going to be somewhere in that range. Okay? How are you feeling about these? Think you could do some of these? Okay. So the second part of your homework is to do this composition of functions that we practiced yesterday. What I want you to do is take a second and see about just setting those up. Don't simplify. I want you to practice. I want you to set up f of g of x, and over here I want you to set up g of f of x. This will just take you a minute, so work on that for me so we can check in and see how we're doing with this piece. All right, so once we have our f of g of x set up and our g of f of x set up, we want to start simplifying. You guys need to show me your work. Okay, I said that yesterday. I'm going to say it again. The setup is worth about half the points. The work is the other half, each step along the way. So if I look at the left-hand side, what's the first thing that I would do? Cancel those 6's, right? I've got a plus 6 and a minus 6. So these guys are going to cancel. What about on this side? The 7's are going to cancel. All right, so let's rewrite what the next line might look like. So I still have the 1/2 outside. I have the square root of 2 times x minus 7 quantity squared, and then I have the plus 7 still on the outside. So that's what this next step looks like on the left-hand side. On the right-hand side, I have the 2, and then I have 1/2 radical x minus 6 squared plus 6. So it kind of is looking good. However, what I'm going to do next is I've got the radical isolated. So because these guys are multiplied, I'm saying this is the square root of 2 and the square root of x minus 7. No, actually, I got rid of the square root. Sorry. When I square it, yeah. So this would be the next step. So the square root of 2, I'm going to leave alone. And when I take the square root of the x minus 7 squared, I get the x minus 7. So here now I have radical 2 over 2 times x minus 7 plus 7. Does it look like I'm going to get to x? I'm not going to get to x. These guys are not inverses. All right, you need to do as much as you can do, though. So if I simplify this a little further, I have radical 2 over 2x minus 7 radical 2 over 2 plus 7 not equal to x, therefore not an inverse. All right, so don't force it. Sometimes it looks pretty good, and then when you start simplifying a note, you're not going to necessarily get to x. So let's just finish up the right-hand side also. So if I'm squaring all the terms inside the parentheses, 1/2 squared is 1/4, and then the square root of x minus 6 goes away. So I have to distribute the 1/4. 1/4 x minus 6/4. If I distribute the 2, I get 1/2 x minus 6 over 2. There we go. Plus 6, which is 1/2 x minus 3 plus 6, or 1/2 x plus 3. Also not equal to x. So not an inverse. Okay, when I'm asking you to verify inverses, the one thing you cannot do is just find the inverse and say, oh, no, that doesn't match. You have to verify through composition of functions. All right, let's check the next one. Let's check the next one. Take a second and set that up for me. So on the left-hand side, there is nothing I can do further. I cannot simplify this any further. I can't simplify 2 terms underneath the radical. If they were multiplication, I could have, but it's addition. This is it. So they're not inverses. Nothing left to be done on that left-hand side. On the right-hand side, if I were gonna simplify it further, I would have to expand the binomial. I would have to FOIL these 2 terms together. So square root of x times square root of x is x. Square root of x times -4 is -4 radical x minus 4 radical x plus 16 plus 16. So you see how this is not going to be x? Just in most simplest terms, which again, we're going to spend some time with, so you'll feel confident doing the middle part, but it's not equal to x. So these also are not inverses. So don't force everything to equal x, because some of them just aren't going to be inverses. I think the next one is. I think the odds are in our favor that the next one might be an inverse. So let's take a look at the next one. We are going to find some of those. Okay. You agree with what David wrote? Yes, even though his colors are not on point. All right, so let's start simplifying. On the left-hand side, I can square everything inside the parentheses. I can take the 3 and square it and get a 9. And if I take this radical x minus 8 and square it, I get x minus 8. So that would be my first step on the left-hand side. On the right-hand side, I'd get to cross off those 8s, and then I have 1/9 x squared. Do you know what the square root of 1/9 is? It's 1/3. And the square root of x squared is x. These guys cancel, and this does equal x. All right, so chances are my left-hand side is supposed to equal x also. So if I look in here, if I multiply this by 9, I get 1. Well, and that's it. So these guys cancel, and I've got x minus 8 plus 8. So I get equal